In this video, I'm going to show you how to use my detail calculator, which you can find in the assignment for the 3D print experiment. There's a link to it, and this will take you to a Google Doc that looks like this. Now you should immediately just download this document so that you have your own copy of it and you won't have the ability to mess up any of the equations. The other things that you should do in preparation for this, you need to go back into Revit and decide what kind of detail are you considering. What are you questioning? What do you wonder, would I be able to see this if I actually modeled it? And for my example, I'm going to model this piece right here. I'll do the modeling in the next video. In this video, I'm just going to show you how to know, is that going to be visible or not after I model it. And I'm going to be modeling this piece of trim right underneath the eaves, and then I'll do this one here right at the top of that parapet. Back into Revit. I've already started sketching what that might look like. And that's kind of my favorite approach to this. I go into a view like the front elevation, and just using those red lines, I start sketching. That gives me an idea of what the size will be. The one that shows up underneath the eave here is pretty small. The one that shows up at the top of the cornice, I'm giving it almost some clunky exaggerations, you might say. It doesn't quite look like this in the picture. It's just the essence of what it does in the picture. It looks like there's a piece right up here at the top, and then it goes down and it sort of steps back or has a reveal and before it reaches the bottom. Now mine doesn't look exactly like that or even anything close, but it does have a band at the top, a large reveal, not a small reveal, because I know I wouldn't see a small reveal. And I've had to exaggerate it because I know a lot of the detail is going to get lost. But how do I know if it's going to be visible or not? That's the question. So you can see I've added some dimensions here. The whole piece is going to stick out 2 foot 2 inches, while the first little step only goes back 4 inches. Those are the numbers that I'm going to need. In addition to those numbers, let's go to the first floor and determine what is the length from one end of the building to the other. I've drawn a line here just to make it fast, 133 feet. Okay, let's go into 3D. Because the only way that I can really do a good calculation is to export this as an STL, throw it into my Prusa slicer, and try to decide how big do I want the overall project to be when it's actually 3D printed. Okay, going back into Revit, what you're seeing right now is a combination of both Revit modeling and SketchUp modeling. And for this quick experiment, I can actually leave it that way. There's no reason to turn off the SketchUp model. The Prusa slicer will recognize all of it. To make an STL, we'll go File, Export, and then I'll choose the STL option. I leave all these settings alone. Click Save and browse to wherever you want to save this. I've done this a couple times, you can see. So I'll call this one number 2 again, and we'll just override the one that was there previously. Now when you do this, if anything is temporarily hidden in this view, it's going to bring up this warning where it's asking, do you want those things to be hidden? If you do, just leave them hidden. If you want them to show up, then click the top option. It's probably worth pointing out here that you do have to be in a 3D view to create an STL. So if you tried this in a front elevation, it's not going to work. Okay, let's go here, and that saved the STL. And then I'll start over in my Prusa slicer. Open up your Prusa software, and then go File, Import STL. We'll go find one of those that I've already created. And you can see it imports it. It doesn't mean that it would actually print all of this because of the combination between SketchUp and Revit. But at least here I get a good preview, and that's all I need. I just want to scale it. I want to find out the size. So I select it, and then down here it says the size of the x-axis, and that's going to be this direction. So I can tell just because that's the longest, the biggest number. So between the x and y, that's really all I'm considering. These are the 2 dimensions on the ground. The 5 is bigger, so it must be from this end to this end. The z refers to the height of the model. Okay, and how big do I want that to actually be? Well, let's say that I want it to be 5 inches exactly. I'll hit enter. You can see it scales the other two accordingly. And now that I have that determined, I'll go back to my spreadsheet and plug in those very numbers. Enter the length of your Revit model's longest wall, 133 feet. And I know that technically in my model that wasn't a complete wall, but that's okay. We just need something that we can compare between the physical 3D print or the STL and the modeling that we did in Revit. So 133 feet, and then what would you like the length of that to be? And I'm putting in 5 inches here. Okay, and then enter the Revit model's wall thickness, parentheses, or object size. The reason it says that is I used to do this just to see if a wall was 1 foot thick, how thick would it be in my 3D print? And I still do that sometimes, but I think I prefer doing it for an object like we're about to do. So in this box, I'm going to type in 2'2" or convert it to inches. That's better, 26 inches. Okay, and the reading that I get down here, the first one says the printed length of your longest wall will be 5 inches. Yeah, we know that. We entered that in ourselves. The 3D printed wall thickness, or in our case object, will be 0.08 inches. And the scale down here is intended to help you quickly find what that really means. What's 0.08 inches? Well, it falls somewhere between a 16th and 3/32. So that's not very big in the real world, but it would show up. I can definitely see something that's 3/32 thick. So I'm not worried about that one at all. That's definitely going to show up. Again, that was in my front view, this distance for the piece that sticks out at the top of my parapet. But how about this little piece that just jogs back, that little reveal right there? That one's only going to be 4 inches. Let's see what it says if I change 26 to 4. 0.013. It's a big difference. 0.013 puts it somewhere to the left of my scale here. It's not even on here. It's smaller than a 32nd of an inch. In fact, it's about 3 times smaller than a 32nd of an inch. So will I see that one? Probably not. It's not very likely. Instead, it's probably just going to look as though it tapers from here and all the way down. And I'm okay with that. When we model in the next video, we'll get to actually see what does it look like when we slice it. But for now, that's just a good way to plan and decide how much detail am I actually going to model.